Hi, I have a lot of jet lag, like an inordinate amount. It's been about 4 years since I did my last international trip, and this one's taken its toll on me, which means I'm probably making some questionable decisions over the past 2 days, and probably will continue to make questionable decisions. There is a legion of things in this room that are high priority and need to be worked on, like the Bendix G15, but that's on hold for a very good reason, and I'll get into that when we get around to working on it. But I woke up this morning with this burning desire to work on the 1144, and it's not on my list of high priority things, but you know what? I don't care. Let's work on the 1144. This PDP-1144 came from Mitch down in Houston, who, in an absolutely legendary move, donated a phenomenal amount of Digital Equipment Corporation, or DEC, equipment to the channel. It was so much, in fact, that it was more than I alone could handle, so a lot of it went back out into the community, again, completely free of charge. I saw this as an excellent opportunity to allow people who may not necessarily be able to afford to get into large-scale computing, especially considering the price of DEC equipment on eBay lately. And so I really wanted to give those people an opportunity to get their hands on with some large-scale systems without having to pay that 4-digit price tag. And so we got a lot of great stuff out there. We got an 1173 all the way to New Zealand. We got an 1144 up into Illinois. We got an 11730 out there, another 1144 somewhere. We got an 1183 out there. We got another 1173 in different places. We had a ton of DEC equipment going in a ton of different places. But this 1144 stayed right here because this one struck a chord with me. It's a pretty special machine. This is actually the last non-large scale integration PDP that was out there. After this, they all kind of went to that PDP-11 on a chip, the J11, I believe it was. So this thing has a massive legion of cards in it on a massive unibus backplane, and I really want to get it going. But well, you guys know me. I like my spinning rust, and so without a proper large-scale hard drive to go with my large-scale PDP-11, it just kind of sat in the corner for far too long, until I got my hands on this big boy down here. This is a Fujitsu Eagle. It is a 10.5-inch plattered hard drive with 480 megabytes. It's a pretty stunningly cool drive, and I've been chomping at the bit to get this thing going, but in order to use this, I need to plug it into this. And in order to get this going, well, that's a long road ahead of us, because this thing is in a completely unknown state with a complete mishmash of cards in it. So I think what we're going to do today is we're going to pull this out, set it on the table, pull all the cards out of it, and take a look at the power supply. I have no idea how far we'll get. That power supply may be totally dead, or it may work totally fine. And really, I have no idea how often I'm gonna be working on this thing. I just had a burning desire to do something with the PDP-11 today. So hopefully it can inspire me and we can get a whole lot more episodes with this machine coming in the future. But, well, the first step is to get this beast out of this cabinet and onto the table. First things first, let's get this DEC rainbow off of here, and because I'm lazy, I'm gonna hoist it all off in one solid go. The 1144 is the topmost piece, so let's pull the top panel off to get access to it. And this front panel might get in the way or get damaged, so let's get it off too. And because I don't want to carry this thing across the room, let's wheel the whole cabinet over to the table. Something about working smarter and not harder. But now that we have it next to the table, let's slide the whole unit out the front. It's a heavy, heavy beast, so it was definitely a bit of a challenge, but we got it there in the end. Next, let's pull the top cover off, and yeah, I've been using this as a card storage box for a while, so not all of these are going to get used in the final build. But for initial testing, though, they all need to come out. So one by one, I'll just pop them up and out and toss them in a box that I can push into the corner for now. With all the cards gone, let's pull the fan assembly out next. And now we're getting to the purpose of today's video, the power supply. With the top cover off, I can get to half of it, but I need to flip the whole unit up onto its side to get to the bottom half of the supply. The last piece of this weird puzzle is the bottom cover over the wire-wrapped backplanes. The power supply on this thing is intense. It's all switch mode power supply, and the switch mode modules are controlled by these like cards here that plug into a backplane. It's kind of like built like a computer all unto itself. It's pretty bonkers, but there's some ridiculously huge capacitors right underneath here. There's another big one right here, and then we've got some transformers up here. And supposedly this thing can do like 120 amps on the 5-volt rail. And if we look at the other side, I totally believe it. And on this side, there's not actually a whole lot to look at. I mean, aside from the insane wire-wrapped backplanes over here, we can't actually see a whole lot of the power supply. It's all behind these massive looms of cables and whatnot. But these two cables up here are the most interesting ones. These are kind of like a flat bus bar thing. I don't know what you would call these. If you know, let me know in the comments below. But these are moving plus 5 volts and ground over to the primary backplane here that's got all the CPU and stuff in it. So I can absolutely believe this thing will do 120 amps off of those. I mean, it even says danger high currents over here. So I think in order to test this, because it's a switch mode power supply, we're going to need to put a load on it. So I'm just going to hook a automotive light bulb up between 5 volts and ground here. I don't know if that'll be enough load. I think this thing is expecting quite a lot of juice, but we'll give that a shot, and then we'll go through and measure it. I can see that we have plus 5 volt here, plus 15 volt here, and minus 15 volts here. If all of those look okay, then I think we're good to put cards back in it and start testing other dumb things. Light bulb is hooked up. HP3476B is also hooked up. What we want to see here is the light bulb illuminate and 5 volts showing up here. What we don't want to see is light coming from anywhere other than the light bulb. That would imply sparks or fire or other problems. I've got the front panel back on because I think I'm going to need to flip the switch on it to actually get DC power flowing. So I think that's everything we need to do. Let's go ahead and flip the breaker on the back here. Okay, let's flip the key on the front. Whoa, that's really bright. We've got 5.3 volts going on there. I can hear a hum out of it, so it's probably a little unhappy that I don't have enough load, but that's excellent news. That is an awesome start. All right, next up, I believe we should be on plus 12 here, so let's see. Nope. Maybe I've got that hooked up wrong. All right, let's try this now. This, I think, should be some kind of 12 volt line. At least that's what the solder mask says, I swear. Nope, I'm not getting anything on that. Okay, let's try the plus 15, minus 15 rails here. We'll go back to ground on that one. Plus 15 on you. There we go, yeah. 15 volts right on the money. It's probably not good that I'm switching this power supply on and off so quickly, but, you know, we're gonna pretend that it's okay. And minus 15 volts, perfect. Okay. I am moderately confident that this power supply is okay to start plugging cards back into. It seems to be putting out the correct voltages. 5 volts was a little high at 5.3, but I think that's because I just don't have enough load on it. This automotive bulb is not going to be heavy enough. For further testing, I want the fans back in place, but they feel a little gummy and could use a cleaning. I'll peel the stickers off the fans to hopefully get access to the internals so I can squirt some lubrication in there. I just need a little something to add lubricity to the existing grease, and that should be fine. Although the third fan looks like it had been replaced at one point because it's very different. I had to remove a center cap to get to the main bearing, but with access to that, it was a cinch to revive it. And with the fans feeling good, let's get the CPU cards back in. And yeah, these are just the CPU and memory cards that I'm putting in. Very much so not large-scale integration. All right, this is a pretty minimum viable setup. I think I've got all the CPU cards in except for the business instruction set because those two cards are pretty rare. So we're gonna save those to the very last once we know that everything is working correctly. And then I've got 2 memory cards in. And other than that, I've got some bus connectors going on here, but I don't have any Grant continuity cards in there. And I don't have any Terminator cards in there. So I have no idea if this is actually a viable setup, but mostly what I'm trying to do is see if things spin up and we get some lights coming on the front here. So I'll go ahead and flip the power switch on here. I'm hoping to see run and DC on. Well, we got run, we got DC on. It's flashing though. I don't know if that's a good or bad thing. If I go to continue, halt, or boot, nothing happens, but heck, we got some life. That's good. Okay, we have a handful of problems going on here. At a very high surface level, the DC on light just continually flashes. The power supply is making kind of a funny noise and the fans never spin up. And all 3 of these things sound like they shouldn't be related to each other, but I think when we dig a little bit deeper, we're gonna find out that all 3 of these things are very closely related to each other. Starting with the fans. The fans should absolutely spin. And on every power supply I've ever come across and every chassis I've ever come across, the fans are almost always 120 volt AC fans, but these are not. These are 35 volt AC fans, which is really weird. And I thought initially that that would just be an extra winding coming off of the main transformer. But no, DEC is much more insane than that. They actually have a collection of logic that creates that 35 volt AC signal. It creates a little square wave that runs the fans. And I've been digging through the manual, and while there aren't any schematics, there's a collection of just really amazing block diagrams here. So if we look at this main block diagram here on this page, we can see that if we look at just fan voltage generation, let's just start with that. There's 3 interesting signals that are going into this. One of them is coming from memory voltage generation. One is memory DC on, and the other one is DC low or thermal shutdown. If we have a thermal shutdown problem, I would think that the entire thing would be shutting off, not just the fans. Although having your fan shut off when it gets too hot seems like a bad idea. But if we dig through the collection of block diagrams here to get over to fan voltage generation, this one here, we can see that essentially we have 35 volts DC coming in, goes into a free running oscillator to 150 hertz, that gets divided by 2 down to 75 hertz, and then it goes into output control. Output control either allows that 75 hertz signal to pass through to the output drivers or not, and then the output drivers are taking that initial 35 volt DC and driving it to the fans themselves. But if memory DC on or DC low or thermal shutdown, if one of these is not correct, then the fans won't spin. And that's actually really interesting because if we go back to this page here at the beginning, right here, we can see that there are 6 voltages that are coming out of this thing. We have +5 at 120 amps, then we have +15 and -15, and this is all coming from logic voltage generation. Those are the 3 that I checked and they're working perfectly. But we also should have another +5, a -12, and a +12. And I checked the -12 and +12 on camera earlier, but I checked all 3 of these again just a couple of minutes ago, and all 3 of these are dead. So we don't have memory voltage generation going on. And if memory voltage generation is not working, that's gonna essentially kick off the output control of the fan voltage generation, and so the fans won't spin. And so I think we might have a problem with our memory voltage generation, but we can also see that we have a bunch of controlling signals coming into memory voltage generation. So whether we have an actual problem with the board that's generating those memory voltages, or we have a problem with something that is controlling that board, I don't know. But I think that is right where our problem is. And if we can somehow fix that or overcome that, the power supply should come back to life. So We've got some more digging to do. I'm gonna start pulling some modules out of here and just looking for anything visually that looks bad. Maybe we can see a very obviously blown capacitor, but we might find that this is gonna require a very heavy deep dive, which we'll get into in a different episode. But let's go ahead and pull these modules out and just take a look at it initially. The power supply has an interesting design. This long flat cable along the top does some kind of AC power distribution. And I know it's AC because I'm dumb and it bit me once. Make sure you unplug stuff before working on it, guys. But with the flat cable thing out of the way, the internal cards just pull straight up. This is awesome for serviceability, but it might be a bit of a nightmare for probing during troubleshooting. Well, kudos to DEC. These are surprisingly easy to get out. There's only really 4 boards, well, 4 units. This is 2 boards, and this one over here is also 2 boards. But I don't see anything obviously bad. Most of these don't even have that many electrolytics on it. This board here in the center has the most, and it's got this kind of janky looking replacement right here, which may very well be the problem, but it's kind of hard to tell without any schematics. I have no idea what that capacitor does, and I don't see any obvious leaking or bulging caps, and I don't see any components that look obviously burned up. However, I do happen to have duplicates of this one and this one. I'm thinking that I'll drop these duplicates in one at a time, and we can at least test if these are the problem. Because if I change it out and behavior remains exactly identical, it's a fairly safe bet that this one isn't the problem. And if we can eliminate these 2 big boys from the equation, that limits troubleshooting to either one of these 2 small ones, which are much simpler and easy to tackle, or something on the main board in the power supply itself. All right, in a stunning display of bad troubleshooting practices, I went ahead and changed out both of these to the spares that I have. Never change 2 things at once, but I'm lazy, so I changed 2 things at once. Don't do this. But what are we hoping to happen here? Best case scenario, we flip the power switch, the fans come on, DC on stabilizes over here, and everything looks like it's working. I'm not that lucky. That is definitely not going to happen. What we're hoping for beyond that is that nothing changes. DC on still flashes, the fans don't come on, but it looks like we have good 5-volt generation. What that means is it eliminates these 2 massive boards from the scenario. And that allows us to focus on these 2 much simpler boards down here, or perhaps some of the capacitors that are on the backplane behind there. Worst case scenario is it changes completely. Nothing works, nothing turns on, something horrible has gone wrong. Let's hope that doesn't happen at the very least. So I'll flip the main breaker on here. And here goes nothing. Oh, the sound is definitely different. The fans tried to spin momentarily. Our DC on light is flashing. That's interesting. Different, but closer to better. Okay, I had to check the voltage rails, and it looks like 5 volts is actually better now. It's 5.1 volts on the nose. Before we were at like 5.3 volts, which was a little high. The power supply sounds a lot better. It's not making that weird feedback noise it was making before, but our DC on is still flashing. So that means that our plus and minus 12 volts is probably not good. So let's check that right quick. Just pull that right off of there. We look at that one there. That should be our plus 12 volts, and we're at 0.8 volts. That's no good, obviously. And if we check our other 12 volt line here, the minus 0.48 volts. So obviously replacing these 2 boards had no effect on our memory voltage generation. Our logic voltage generation, though, does still seem to be good. So our fault is someplace else. That might make troubleshooting a little easier, hopefully. All right, it's going to be almost impossible to see, but given that we've replaced pretty much all of the modules and we're still getting the exact same behavior, I'm inclined to think that the failure's on the motherboard itself. And all of the caps look really good, so I started looking at potentially other things that might have gone wrong. And on the motherboard assembly here, we can see that the plus 12 volt rectifier is right up here. It's D6 and C3. And those are on the motherboard as opposed to on one of the cards like the other rails. And so that was a little suspect. So I figured I'd check the diode on it. And well, we can see that in one direction, we're getting a 0.6 volt drop across that diode, which is totally expected. But if I swap the plugs around here, we should actually be blocking. That's what a diode does, right? And if I switch them around, we get a 0.45 volt drop across that diode. Now, I'm checking it in circuit, and checking things in circuit is always finicky. So this could be totally fine, or this diode could have broken down and it's not doing any dioding anymore. Unfortunately, it's in a really difficult place to get to, so I'm not exactly sure on what the best path forward with this is at the moment. Well, I guess we're doing the thing. Let's just pull the whole PSU out. The flat power cables come off easily enough, but these big boy connectors up top are a packaging nightmare. Everything is so tightly crammed into a tiny space that nothing wants to move. With everything unplugged though, I'll go through and unscrew all the securing screws, and there should have been about 8, but only 4 were installed, which is a bit telling, I think. Then the whole thing just pulls right out, is what I want to say, but the truth is it took like 10 minutes to walk this thing out. It's just really, really tightly packaged in there. But with it out, let's get this power distribution board out. It's held in with 6 screws that go into bus bars, and with those removed, it slides right out easy peasy. And someone has replaced the capacitor back here before. The green bodge wires, I think, are factory though, because they're all over the place. But this cap, it's definitely not original. At any rate, the diode is what I want to check, so let's desolder it and pop it out. And with it hooked up to the multimeter, yeah, it's totally fine. That's not surprising, but a little disappointing. Well, I think I'm gonna have to call it here. At this point, without any schematics, I'm really just kind of flailing, looking at random components in general areas that might be suspect, but there's such a complex system going on here that unless we have something very specific to follow and test, it's going to be really difficult to get this power supply up and going. It's so close, and I'm not going to give up on it, but I think this is going to take a lot of time off camera, pouring through manuals, trying to understand exactly what's going on so we can narrow down fields that we need to check in. I think, man, I am moderately confident that the problem is not on one of the boards that you can pull out, because I've replaced almost every one of those with other ones, and the behavior is identical. Yes, it's totally possible that my spares have failed in the exact same way, but that would just be really unlucky. So I'm hoping that's not the case, but until I understand more about what exactly is going on, why it isn't working, and where to check, I'm kind of at an impasse here. So, like I said, we're not going to give up on this. We are going to revisit it, and we're going to get this going because I really want to get that 1144 going, because I really want to play with the Fujitsu Eagle that's attached to it. So we've got a lot of work to come, but we didn't quite get there in this episode. But regardless, I want to thank you guys so much for watching, and I hope to see you in the next episode.